All right. Good evening. Um, Today I'm going to discuss with you the notion of differentiability. All right. So, what do you understand by differentiability? Either Krishna or Shikhar. What does it mean for a function f of x to be differentiable at a point? Let's say a. No, no clue. Krishna must have encountered the idea of differentiability by now.
Yeah,
Yeah.
like
Tell me.
differentiability is used to calculate. I don't know like how to say a function is differentiable,
Okay.
but then I can tell you about where it's used.
Okay. Where is it used?
Like suppose if you want to calculate a particular thing at an instant, like say instantaneous velocity in physics and chemistry, instantaneous concentration,
Okay.
then you'd use differentiation to do so.
Okay. So what we do is take the notion of a slope, right? So for a straight line, we know the notion of a slope. How do we find slope of a straight line?
Y is equal to mx plus c.
Yeah. How do I find m? I give you a straight line. I want to find m.
Yeah, y2 minus y1 by x2 minus x1.
Okay. So let's begin with that idea. So now I have m equals y2 minus y1 divided by x2 minus x1. That is, if I have a straight line, suppose I have a straight line like this. Here is the origin. So suppose this is y equals mx. I'll take a look at 2 points. Maybe this one is x1, y1. Maybe this point is x2, y2. Then I have this notion of slope, which, what does the slope tell me?
It's the solution of y.
The solution of?
It tells you the it tells you the angle it makes with respect to the x-axis.
Okay, but I have this y2 minus y1 divided by x2 minus x1. And when you look at that, what does that tell you?
It tells you
If I move x2 minus x1 units on the x-axis, how much would be the movement on the y-axis? How much will be the change along the y-axis if I made a change of x2 minus x1 along the x-axis? That is exactly what
y2 minus y1.
Yeah, that is going to be the change in the y-axis. And x2 minus x1 gives me the change in the x-axis, so that I can see per unit change in the x-axis, how many units of change do I get in the y-axis? Right? That is exactly what the slope tells me.
Yeah.
All right. Now, instead of a straight line, I now have a curve. Here is x, here is y, here is 0. Now instead of y equals mx, I have y equals f of x.
Yeah, so here's where differentiability comes into play, because it won't be as straightforward as your straight line.
Yeah.
So, but you can think of it as it's comprising of many different straight lines.
Okay.
So based on that, you differentiate to find the rate of change of y with respect to x at a particular point by dy by dx.
Okay. So exactly I have right notion, Krishna. So now I have this point A and I define the so-called difference quotient. Difference quotient. And what is the difference quotient? I generalize the same idea of slope now to the notion of a difference quotient. Suppose I have this point A, I'm going to look at f of A plus h minus f of A divided by A plus h minus A. What does that mean? I am again looking at what is the y value of the function at A plus h and what is the y value of the function at A divided by what is the x value? X value is A plus h. This is looking like x2 minus x1. Here y equals f of x2, which is equal to this, and here y is equal to f of x1, which is f of a, because x1 is a. So exactly the same notion of, so here is a, maybe I'll take a plus h here. So here is the value of the function. What is this point? What is the value of this y value of this point? Krishna, what is this point? This first point. A plus h.
A plus h.
F of A plus h.
Yeah.
What is this point here? A, f of A.
Yeah. F of a.
Yeah.
So that's how you derive this.
Not yet.
Wait, what's your question?
The question is, what does this f of A plus h minus f of A by A plus h minus A, what does that give you?
So it gives you y2 minus y1 by x2 minus x1.
So that is called the difference quotient. So again, for a unit change in x, how much of change in y am I getting? That is exactly what I'm computing, right? But now what I'm going to do now is I'm going to let this h probably was, if a was here, a plus h was here. I'm now going to let this h go to 0. In the limit, as h goes to 0, f of a plus h minus f of a divided by h. If this, now what is the thing about limits? They may or may not exist. If this limit exists, then I'll call it f dash of a. Fine? So f dash of a is nothing but limit as h goes to 0, f of a plus h minus f of a divided by h. So what's the difference, Krishna, now between a straight line whose slope we were finding and now the difference quotient whose limit we are finding? So what are we doing? We are beginning to let this h go to 0, which means this a plus h will slowly come towards
A.
Exactly. And I can also have h to be negative. I can do this from both sides of a. I can do it from the right side.
Yeah, exactly. Yeah.
And I can do it from the left side of a. And this limit, if it exists, I will call that the derivative of f at the point a. Is that fine? Do you see that I am trying to generalize the notion of a slope from that of a straight line to
To
any
that of a curve.
of x.
Yeah. I
Yeah,
got it.
yeah. So when we try to generalize this, in the
So
limit,
f prime of a is the differentiated version of
f,
the function.
yes, at the point A.
Yeah, exactly. Okay.
So when I
Differentiating
say
with
this
respect to
limit
a.
exists, when I say this limit exists, this means if I have the left-hand limit as h goes to 0 plus f of a plus h minus f of a by h. This is the right-hand limit. I am coming to a from the right slowly. That limit should be equal to
The left-hand limit.
left-hand limit. Limit as h goes to 0 minus f of a plus h minus f of a divided by h. If these two are equal, then that will be the limit, and that will be exactly the derivative of the function at the point x equals a. Any questions?
Yeah.
Krishna, any questions from you? Shrikar, any questions?
No, sir.
So I'm basically, as Krishna was saying, I have this straight line. As I'm beginning to go closer and closer, I'll get different set of straight lines, and in the limit, as I approach a, what does that difference quotient become? If it goes to a stable value, then that is the derivative of the function at the point a. I can come to the point a either from the left, or I can also come from the right. I can come from right, I can come from left. Doesn't matter. It has to go to the same value. If when I come from the left, it goes to one value, and if I come from the right, it goes to another value, then the limit is not going to exist, in which case,
So for the given function to be differentiable,
excuse me,
if the from the left it should be equal to when you do it from the right.
yes,
So for the function to be differentiable, the
yes,
left-hand limit should be equal to the right-hand limit.
that's right, exactly.
And when you take continuity, it should be equal to f of x also.
Yeah. So for continuity, what do you have to? You don't have the difference quotient in place.
Okay, yeah, I got it. Yeah.
Limit as x goes to a plus of f of x should be equal to limit as x goes to a minus of f of x, and that should be equal to f of a. If the value of the function at a equals the limit as I approach the point from the left or from the right, then such a function is continuous. And the derivative exists if the difference quotient, whether I come to the point from the right or I come from the left, either way, if the limit exists, then the function is differentiable. Good? So,
Yeah.
shall we take a nice problem that was asked in one of the exams?
Yeah.
Okay.